Okay, so you're on your own for the calculations of our mystery metal lab. So I figured I'd go through some of mine to help you guys out. So first off, let's fill in my data from the lab. My mass from the first trial was 0.024 grams. My mass from the second trial was 0.031 grams. And the third trial I used 0.028 grams. Now, to read the initial volume of H2 and the final volume of H2, I looked at the eudiometer and where it was at. The first trial, I didn't start with any water, started with 100% water and 0 gas in the tube. So we'll say it's 0.0 milliliters. And at the final stage, it was 26.2 milliliters. So then I took the 26.2 milliliters and I didn't refill it or anything. I just started from there and I made it to 55.8 mils. And the third trial, I started at the 55.8 and made it to the 79.9 mils. Now, we can take these measurements and actually find what our metal was. And what I'm going to do is I'm going to walk you through just trial 2. Okay? That way, you guys will have trial 1 and 3 to do on your own. It'll be the same stuff regardless. And I'm thinking trial 2 will kind of cover everything everybody else did. Plus, I think it's my closest data point to what it actually was anyway. So we're gonna go from here and see how we do this. Now, you've got number 1 to fill, which is the liters of H2. So to find the liters of H2, all I need is how much H2 filled in here. Remember, there was a eudiometer, right? And it had the markings as it was going down and whatnot. And we're basically finding the difference between where it started and where it ended, right? What was that difference? How much gas actually filled into the tube as we're going along? So I have my final reading of 55.8 and my initial reading of 26.2. So I'm just going to subtract those. And I get 29.6 milliliters. Now I need to convert that to liters. There are 1,000 mils in a liter, or 10 to the third milliliters in 1 liter. So I'm just going to take 29.6, and I'm going to put milliliters on the bottom, put 1,000 down there. That's 1 liter. This is a fence post if you can't tell. And I'm going to end up with dividing by 1,000 or just moving the decimal over 3 places. So that's 0.0296 liters. Now, I can take those liters and I can move on from there. First, I'll go back, fill in my data point. And you'll just go back and do this for everything else as you're going along, right? You're going to fill in trial 1 and trial 3 and whatnot. So next is number 2, which will bring us to moles of H2. Okay. So the moles of H2, to figure this out, I'm going to take the liters and just do a single fence post to moles. And we know that there are 22.4 liters in 1 mole. So we end up dividing, and the number I get for there is 1.38 times 10 to the negative third moles of H2. Okay, then I'm going to go for, and we'll see if this is still on the screen, moles of X, which should be number 3 on our list to figure out. Okay? Now it's going to involve taking the moles of the hydrogen gas and converting it to the moles of our new metal. So I want moles of X, right? Because I want to go to our metal. Now, for this, I'm going to look at the number that's in front of X and the number that's in front of H, 2, and you can see that they're both 1. So I'll fill this in with 1 and 1, and yes, the math is going to be super simple, and I'm going to end up with the same number, but a different unit. Okay? Now, I want the molar mass, and molar mass is grams per mole. Well, I have my moles there, and my grams you actually measured on the scale. So I'm going to take 0.031 grams and divide it by the 1.38 times 10 to the negative third moles. And when I do that, I get 22.5 grams per mole, which is the molar mass that I'm looking at my periodic table right now, trying to figure out where 22.5 is, and it's pretty close to looks like sodium. Okay. Now, obviously, I didn't give you sodium metal because your hands would have, lit on fire, and it would have really hurt. So I wouldn't do that to you. What you should get is magnesium. Obviously, my trial is a little off here, and you're going to have to find some averages and do a percent error calculation. I've got the formula right there for you. It'll be easy peasy as you're going through. And then you're going to write the letter to the royalty to let them know that those iron bars were made of either magnesium or whatever you find it to be, or at least it's not iron, and that's the important part. So we've got some interesting stuff coming along. We'll get there, okay? So you have to have this lab done by the end of the day today. Make sure you hand it in, and we can move on from there, okay? I'll see you tomorrow.